looking at laws of logs, we're going to first look at the sum of logs. And we're not going to do every single part because you'll kind of see a pattern, but for some we will. So that the first part here is going to help with all of them. So fill in these values. What's the log of 2 base 2? You do not need a calculator, and you will see a pattern. So fill in the values of each of those logs. And then we're going to use those to help us come up with.
Thank you. It was almost everyone said that. That was really nice. Thanks, guys.
Okay, filling in the values. Let's go. If you can count to 10, you'll be able to fill in these values. Log of 2 base 2 is 1. Log of 4 base 2 is 2. Log of 8 base 2 is 3. You have to see a pattern. Right? 2 to the what gives you 16. 2 to the 4. 2 to the what gives you 32. 2 to the 5. 6, 7, 8, 9, 10.
But you like throw in like the levels just to see if there's any in it.
I should have missed one in there. Okay, so let's take a look. We've got all the values there, so you don't have to think so much when you're actually filling in these expressions. So it says log of 4 base 2 plus log of 8 base 2. So let's evaluate each part. Okay? So this log here has a value of 2. This has a value of 3. We add those together, we get 5. Okay, and we've done. That's simplifying it. Now, how can we show 5 as a log? Single log with base 2? Well, that would have to have an argument of 32. Okay, so log of 32 base 2 is 5. So every single part there is equal. Normally we don't show equal things when we simplify along a horizontal line. Usually I get mad at you guys for doing that. But we are doing it in this case just to see the patterns. Right? So then this here, log of 2 base 2 is 1. Log of 32 base 2 is 5. If you don't remember, you go up to what we answered there. 1 plus 5 is 6. Log of what is base 2 is 6. Well, you can take a look if you're not sure. It's 64. Okay. So let's do one more and then let's look for some patterns. So log of 8 base 2, that's 3. Log of 16 base 2 is 4. 2 plus 4 is 7. Log of what gives you 7? 128. Take a look at these values compared to these. Because often we're going to be asked to simplify a log expression into one single log. Well, they all have the same base, first of all. So base 2, in all of them. 4 and 8, 32. 2 and 32, 64. 8 and 16, 128. What's special about those numbers that I just listed off, those arguments? How do they relate to each other? They're factors of this argument. So 4 times 8 is 32. 2 times 32 is 64. 8 times 16 is 128. So what that is saying from these examples is if we want to simplify the sum of 2 logs that have the same base, all we have to do is multiply the arguments together. Okay? If they don't have the same base, then you can't do this. But if they have the same base, you can multiply them together. Similarly, you can go backwards. We have something like this, and we want to split it up into more than one term, then we can look for factors. And that's going to be more helpful when we deal with algebraic expressions with logs, maybe with some variables in here. Splitting it up will be helpful. Okay, so that's basically the pattern. I'm not going to spend the time going through these. it's going to show you exactly what we just did, okay, or what we just figured out. So we've done this comparison. So now let's do some questions where we want to show it as a single log. So we've got log of 2 base 2 plus log of 8 base 2. What we just learned is that argument 16. Okay. You might think, well, why bother? I can find the log of each of those separately. It will be helpful. If sometimes the argument you won't be able to do without a calculator, right? Maybe this is a 3 and this is, I don't know, like a 6 or something, whatever. Separately, depending on that base, you can't evaluate them. But when you multiply them together with whatever base it is, you will be able to simplify them. Also with algebraic.
Yeah, that's what I was going to say, like solving logarithmic equations makes it a lot easier.
Yeah. With algebraic, either expressions or equations. Just in terms of simplifying, it really depends on what base that is. Okay, so then here, adding, make sure the bases are the same, so then we multiply the arguments. Adding, bases are the same, so multiply the arguments. Adding, bases are the same, multiply the arguments. Okay, so we're just simplifying it to one single log term. Okay, so now in general, same base B, adding the logs, nothing in front of the log. That's really important when we get to algebraic expressions. We cannot have a coefficient in front. We can, there's one exception, or an exception, if those coefficients were exactly the same, but rarely are they. So we want to make sure that coefficient is 1 on each of those logs. And then if they're the same base, you can show this as x1 as your argument. Going the opposite direction, then if we've got the log of some number, some expression that's a product, we can split it up into the sum of 2 logs. Okay. So in words, the sum of the logs of 2 numbers is equal to the log of the product of the 2 numbers. Vice versa, the product of 2 numbers, the log of the product of 2 numbers is equal to the sum of the logs of the 2 numbers. Okay, so use your rule to express log of 64 base 2 as a sum of 2 logs and in at least 5 ways. 1 way's been done for you. You do 4 more ways.
So happy. Oh yeah.
So who has one uncheeky answer?
Yeah, I do.
An uncheeky, yeah?
Well, no, wait. If I do this, I can't say my cheeky, so.
Okay. Who has an uncheeky answer?
Log 2 of 32 plus log 2.
Good. 2 and 32.
0.5 from the other.
Okay, yeah. Getting a little cheeky, not too much. Yeah.
Alright, can I say my cheeky?
Yes, you can.
Log 2i plus log
Oh my God.
negative 32i. It works! Oh yeah.
You said 32i?
2i and 32i. Negative 32i. There you go, that works.
Well, i's a complex number, so these are, I don't know, that defines in,
Well, it depends on what log you click. Is a complex log?
I don't even know, so, this is Jackson's TV. So I is the square root of negative 1. I don't know if we can put that in a log. Yeah. Anyway, we're going to skip that one in terms of our real. We can still be cheeky, but in the real number system. So we've only got 1, 2, 3, 4. Need another one. One uncheeky one. You're missing one. Valeria? Yeah. What about okay, let's do another. So what would my argument have to be in this one if this was the first one? One over 64, right? Okay, that's a bit cheeky, but.
Log 2, 10.5, and then plus log 64.
Oh, 10.5 plus log.
No, 10.
Oh, yeah. 10, what did you say?
45.
45 degrees, yes.
64, 10, 45 degrees.
Don't laugh. That kind of thing is on the diploma exam.
What? Hey!
Good for you. Gavin.
I'll just guess the rest of the
Oh, wait. Actually,
That's 10 and 45.
Not
Yeah, so log of 1 is 0. Plus log of 64 base 2 is log of 64 base 2. It is. It's legit. Okay, let's focus in a little bit. Quiet. Okay. Yeah, just a second. Quiet.
So log 2 of 0 factorial plus log 2 of 4 factorial plus 40. No, sorry, 4 factorial plus 40 in brackets. Because that's 24. Yeah. Or we could go on the gamma function definition.
Okay, so this one's cheeky as well. So 0 factorial. We're going to talk about this in like a week or two when we get to combinatorics. 0 factorial actually has a value of 1. And then 4 factorial is 4 times 3 times 2 times 1. So that's 24 plus 40 is 64.
So why is 0?
It's basically gamma function definition.
Well, I'm not going into the definition. We'll look at the definition a little bit later. If we look at permutations, you'll see what happens. Okay, so I think we've done enough of these. We get it, right? We can split it. This said into 2 log terms. We could split it into more, right? 64, we could go log of 2 base 2 plus log of 2 base 2 plus log of 16, right? 2 times 2 times 16 is 64. So you can split it up however many factors you can have, okay? But this one back here, where we had a tan within a log, That I've seen on diploma exams, but not this particular example, but maybe evaluating something or, that way they're actually being able to test more than one concept in a question. Okay, so be aware. Maybe that's a good cumulative exam question.
By the way, I just checked my super TV one. It works.
Good. Okay,
As long as you switch to A plus B.
so this is just the same. I just copied this. We don't have it. Let's focus, folks. So now let's look at the difference. Let's just in general think. If we're multiplying logs with the same base, or sorry, what did I just say? If we're adding logs with the same base, we multiply the arguments to get it to simplest form. Now, if we're subtracting logs with the same base, what do you think we do to the arguments to get it to simplest form? Divide, the opposite, right? So let's see what happens here. So here we're subtracting, and log of 64 base 2 is 6, log of 4 base 2 is 2, subtract is 4, so that's going to be 16. Well, 64 divided by 4 is 16. It works. This one is 5, this one is 3, 5 minus 3 is 2, log of 4 base 2 is 2, 32 divided by 8 is 4. Okay, so we use some reasoning skills to figure this out. I'll leave the rest, you can fill that out. It's all just a matter of evaluating each part. So it says for each of the above, compare the first and the last and use the results to predict the following. So what we did, even before we started, we said if we're subtracting logs with the same base, we divide the arguments. 256 divided by 4 is 64. Remember, the coefficient in front has to be the same, preferably 1. If it's the same, you have to do a little bit more. In any case, here, dividing, that is what, 8? Dividing is 16, I think. Okay.
Oh, well, you have to be careful with this one. Because it can't be log 2 or log 2 of 1. You can't
Right,
use
here, you can't use that, exactly. Okay, so then here, simplifying this, make sure they're the same base. If we're subtracting, then this is going to be x over y. Okay. Here, we can start with x over y and then split it up. So the difference of the logs of two numbers is equal to the log of the quotient of the two numbers, and the log of the quotient of two numbers is equal to the difference of the logs of two numbers. Your formula sheet. Laws of logs, so we've just done the first two in your formula sheet. The fourth one we did yesterday, change of base, and now we're going to look at the third one. You guys aren't sharing a drink, right? During COVID times, where you're sharing the same straw and everything. Like, no, you wouldn't be doing that. Okay, log of a power. So, to determine the log of a power, we can split up, right? 2 to the 5th, the same as 2 times 2 times 2 times 2 times 2. We can show that as a sum of each of those separate logs. And take a look at that. These are all like terms. They're all exactly the same. So we have 5 of them. So that can be shown as 5 times log of 2 base 3. So how does this relate to this? Because we're never going to show all the steps in there. That would take you forever. I'm doing this to find a fast rule. Take a look. So this is log base 3 in both of them. 2 to the 5th. Now that 5 becomes the coefficient of the log, right? Because that 5 means there's 5 equal factors of 2. So these are 5 separate terms. So we show it as 5 log 2. Here, copy out, same base, copy out the base of that exponent. That 3 goes in front. Okay. That 4 goes in front. If you're not sure, you don't believe it, then let's do it. Let's go math log base 6 of 4 to the exponent 3. And let's go 3 log base 6 of 4. Okay, and get exactly the same thing. Okay. It is not equal to log of 4 base 6 all cubed. Okay?
All multiplied.
Correct. So be careful on that. Usually there's some kind of question that involves knowing the difference between those. Okay, so for each statement above, compare the first expression to the last and complete the following law of logs. So here, I'll leave a bit more space. So that n goes in front, log base b of x. So the log of a power is equal to the exponent times the log of the base of the power. And sometimes we actually do the opposite of this more frequently. Remember how I said with when we're adding logs together, you can show it as a single log by multiplying the arguments. They have to have the same coefficient. So if it doesn't have the same coefficient, we're going to need to show it as an exponent there in order to use the product word. All right, so that's the end of that lesson.